All right, guys. This is going to be section 6.4, which are properties of integrals. We start with the definition, just saying that the integral is the area of a region. So if y is equal to f of x is a continuous, a non-negative on a closed interval ab, then the area of the region bounded by the graph of f, the x-axis, and the vertical lines x is equal to a and x is equal to b is given by this, right? And if I was to kind of make a small drawing of it, this is my x and y value, this is my function, this would be a, and this would be b. So this would be the integral. This area would be the integral from a to b of f of x with respect to x. Okay. So that's pretty much it for that one. All right, let's look at example 1. It says use a graph below to evaluate each of the following. Know that the graph of f of x consists entirely of a line segments and a semicircle in the intervals from -8 to 13. So we see that here. And just to see the kind of questions they want us to answer is going to be the integral of 0 to 7, 0 to 13, and so forth. Okay. So let's just take a look at one at a time. The first integral they want us to do was the integral from 0 to 7. So that would be this integral here from 0 to 7. That would be this area. If I was to kind of maybe shade it or highlight it, that would be this area, right? Now, there's two ways of doing it. You could count each little square, or another thing I'm introducing that I didn't teach last time we were doing this is using the area of a trapezoid, okay? So we could actually analyze this area, the integral from 0 to 7, can be the area of a trapezoid, which is going to be 1/2 the height times the base 1 plus base 2. So I see that base 1, or whatever base, is 3, and this base is 7. So I do that and I get my height of 4. So I just want to have 1/2 times 4, and then 3 plus 7. And if you do this, you get 10 times 4, that's 40. And when you divide by 2, you get an area of 20, okay? So by looking at our area as a trapezoid, we see that this area is going to be 20. Now they want us to get the area for B from 0 to 13. So if I go back from 0 to 13, well, I know I have to add these areas, right? From 0 to 7 and from 0 to from 7 to 13. And one's negative, so we already know from the previous lesson that when we have a negative area, we're just going to subtract it. So the integral from 0 to 13, f of x dx, can be expressed as the integral from 0 to 7 plus the integral from 7 to 13. Okay? And we already have 0 to 7. We already said that's 20. So I could just rewrite this as 20. Okay? Plus 7 to 13. Now this integral, because it's below the x-axis, we're going to make this a negative integral. Okay? This is going to be we're not going to make it a negative integral, but we're going to express the area as a negative. So same thing, I have a trapezoid. This base is 3. This base is 1, 2, 3, 4, 5, 6. So if I use that area, I could say this is equal to 1/2. And then the height of this is going to be 3. So 1/2 the height times base 1 plus base 2. And if we add that all together, you get 9/27 over 2. So I have 20 plus 27 over 2. And I guess I could make these same denominators, right? So I could add them. So I'm going to have 40 over 2. But remember, this is actually going to be a negative area. So instead of plus, or I should include a negative area, make sure that you include that. And you're actually going to be subtracting these. So 40 minus 20 is 20. Minus 7, you're going to end up getting 13 over 2, or 6.5. Okay? And that's how you would do that one. Okay, now how do I go from negative 6 to 0? What's the area from negative 6 to 0? From negative 6 to 0, we see that this is a circle, right? Semicircle. So we just find the area of a circle and we just get half of it. From our previous lessons, the area of circles pi r squared. So first figure out what your radius is. And I located my radius here, which goes from negative 3 to 0, or 3. All right, so the area of this circle is going to be equal to pi r squared, or 9 pi. But since we only have half of that, we're going to have to divide that by 2, okay? So this should be 9 pi, but because we only have half, is going to be 9 pi over 2. So the integral from negative 6 to 0 of f of x dx is going to be equal to 9 pi over 2. And then we kind of looked at this one before. If you get the integral from 3 to 3, just kind of think of it, you're not really going anywhere, right? It's just kind of like the small infinite line. So when you have that, we're just going to say that that's going to be equal to 0. And think of it like you don't have a rectangle. It doesn't have any area. Okay, for E, this one's interesting because you're going from 7 to 0. We talked about that. When you go from 7 to 0, you're actually going backwards. Okay, so we have to change that. Now we know the area from problem A, that this area from 0 to 7, it's 20. But if you were to go backwards, we said we just make it negative. Okay, and algebraically or with the properties, we will say the integral from 7 to 0 of f of x dx is going to be equal to the negative integral from 0 to 7. Okay, and since we already know the integral from 0 to 7, it's 20, this answer is just going to be 20 for us. Okay, negative 20. Okay, and then 10 to 4, you would do the same idea. From 10 to 4, we would actually break it up and say, how about we go from 4 to 10, and you would make that negative. And I'll let you guys do that one on your own. And I'm just going to give you guys the answer. Okay, the complete answer is going to be negative 1/2. So maybe you could pause the video and take a look at that one. And then for G, from negative 8 to 13, it's you're pretty much adding all of them, right? From negative 8 to 13, you're adding and subtracting all the areas. And again, I'll let you guys do that one on your own. And this would be 10.5. Now, H is a little bit interesting because they're not asking you for the integral, but they're asking you for the derivative, right? It's if you take the derivative of f at negative 6, so they give us the function f of x. So we're looking at, again, just to be correct, negative 6 right here, right? This little area here. So if we were to look at this slope, you kind of have a negative slope, but then the graph turns into a semicircle, which you still have a negative slope, but it becomes a lot steeper. And one could say, even argue that it goes to an infinity level, right? Because it's as the circle is approaching that area, that place, right? If I was to draw a circle, you see that the slope is getting really, really steep. So that might be approaching infinity. And when you have that, we're just going to say this is a cusp, and the area, the derivative will not be defined, okay? So this would be undefined for that reason. All right, let's continue. What about the second derivative of 6? Well, let's go back to the graph they gave us. Okay, 6 is here. Remember, this is f of x, so the derivative of f of x, we see that this slope is going to be a constant, right? And you could calculate it if you wanted. It's just going to be 4 over 1, 2, 4 over 2, or negative 2. And we see that that's a constant, so the derivative at that point is a constant. So the second derivative at 6, and we know that the derivative of a constant is going to be 0. So our answer is going to be 0 for this one, okay? Our answer is 0. And then if you wanted to find the average rate of change between 0 and 5, you guys know how to do the average rate of change. I'm not going to go over that. I'll just give you guys the answer. The answer is 4 over 5. Quick question, true or false? The integral of 0 to 2 of f of x dx plus 2 to 4 is equal to 0 to 4. What do you guys think the answer is? So real quick, 0 to 2 and 2 to 4 is the same as 0 to 4. Let's look at the function. Okay. 0 to 2, 2 to 4. Would that be the same as 0 to 4? And if we go ahead and see that, we see that the answer is true. Okay. Then the last question, over which values of x is f of x not differentiable? And again, we're just looking at all the little connection spots, and this would be all the points where you have like these sharp turns or cusps. And that's pretty much all those points, okay? All right, that was example 1.